Our next speaker is Nick Zentner. Nick has a bachelor's degree from University of Wisconsin and a master's degree from Idaho State University. He has taught at Miami University in Oxford, Ohio. Also, he joined the staff here in 1992 and has been here ever since. And so we're very happy to have him. He has put together his program, Nick on the Rocks, and given many presentations on geology of the Pacific Northwest and many, many issues. He's become an expert on the Missoula floods, many other issues of tectonics and geology in the Pacific Northwest. He has 2 Emmy Awards for his Nick on the Rocks series from PBS. And last year, he was awarded the prestigious Geological Society of America Public Service Award. So that's a very high recognition. And I think I'm just going to shut it off there and let Nick come and talk to us about Liberty Gold and the Challis magma.
Thank you, Julian. Appreciate it. Good afternoon, everybody. So we're going to go for it. Liberty Gold and the Challis magmas. So right off the bat, I have learned from a variety of sources about the gold, but I'm really interested in stories, plate tectonic stories, regional stories. And my interest in the gold is not probably your interest in the gold. My interest is how the gold tells a story about host rock. What is the host rock? Why is the host rock there? There's magmas. That's a regional story. Is there an old story with the Challis magmas? There is, but there's an emerging new story that I'm making new programs on. And new research that's been published in the last few years puts this Teanaway Formation into a new set of eyeballs. That's the plan today. Did I say fast-paced? I didn't even go past the first slide. Let's go. All right, so gold, we've got it. Liberty, I know you're from all over the place, so I want to make sure we know where we're talking about. But these are photos from a guy named Rob Reppin, and I've learned a lot from Rob Reppin. And this is my classroom. I teach Geology 101. And 10 years ago, I started opening the 101 up to the public. And I got a phone call in the old building when I was teaching 101 over there. He says, yeah, I mine gold up at Liberty. Is it true? I heard a rumor that you open your 101 class up to the public. Is that true? I said, sure it is. He said, when do you meet? I said, every morning at 10 o'clock. He said, I'll be there tomorrow. So he did the whole 101 class, probably a 45-year-old gold miner, in the winter quarter of whatever it was, 2013. And at the end of that class, he started teaching me his stuff up in his mine, both his placer and his hard rock mine. So much of what I have got going with Rob Reppin. These are Rob's photos. He's got a quartz vein, he's got some black shale, and he's got crystalline wire gold. Liberty, just to the north. This is Rob, the guy I'm talking about. Tied pretty closely with the Liberty Gold story are these blue agates. And I know some of you have blue agates in your pockets right now. So the idea is the blue agates may have a very specific tie to the gold or may not. That's one of my main questions. And we might get a discussion going if I'm successful here. So if over the years people have come in with blues, I say, can I take a photo? Like, Julie, I need to take a photo of that you showed me a few minutes ago. So this is Washington. You are sitting right here in the middle of the state, Central Washington University. Seattle over here, channeled scablands of the Ice Age floods off to the east. And Ellensburg is here. So we are talking about an area to the north of Ellensburg, and this is the county line between Kittitas County and Chelan County. Is this Chelan County? Blewett Pass, right up in this general area. Blewett Pass, US 97. That's the new Blewett Pass. But there's an old Blewett Pass, as many of you know. So this is US 97 today, up and over Blewett and heading down towards Leavenworth and Wenatchee and Peshastin and so on. But this old Blewett Pass is also still in existence. The road that was the main pass before the mid-1950s. And I love driving up on that old road. Some of you, I see you're nodding your head, so you know that road. So here's an old Echo Point. And there's the Echo Point back in 1922. And this pavement hasn't changed since 1956. It's got a bunch of potholes in it now, but it's still a pretty good road. And there's excellent geology exposed along that road. And here are folks back in the old days backing their way up over Blewett Pass. Backing their way. Single file. So a gorgeous map here, or depending on your, maybe you think it's ugly, I don't know. Here's Liberty. Here's Squaw Creek. Blewett Pass is up here. Here's Mission Peak, Mission Ridge, skiing coming up from Wenatchee. Here's Challis, Ellensburg's down to the bottom of this screen. Okay, so this is a mining district that's been going for more than 100 years, easily, sluicing along the Squaw Creek. I know many of you have detailed and long histories with this area. Many of you own property and claims. Looking to learn from you. Got it? Been there. Now the geology is my game and the broad geology is my game. So we have a beautiful landmark. Liberty's down here in the hole. So we have Mount Stewart and the granodiorite of the Mount Stewart batholith. This is rock from the age of the dinosaurs. And depending on who you talk to, this is rock that was originally formed in Mexico and then moved to northern Washington. Or less wild people say it's California granite that got moved here. But regardless, there are enough strike-slip faults to say that this granodiorite of Mount Stewart has not always been in Washington. That is a safe statement to make. That plays a very small role in this story today, however. The Columbia River basalts, or the flood basalts, or the Yakima basalts, or the German chocolate cake, that is coming to an abrupt end here at the north edge of Table Mountain. So we don't have the Mount Stewart granite to talk about today. We don't have the Columbia River basalt lavas, but they're both within a stone's throw of the Liberty Gold District down here in the hole. What is the geology down here in the hole? So here's a cross-section from Mount Stewart to Ellensburg, north off to the left, south to the right. There's the Stewart granite. There's the Ingle serpentinite, which is even older rock from the bottom of the ocean. Not our story today. The Squaw Formation, sandstones and shales, are abundant. And if you go up on the old Blewett Road, you'll find all sorts of plant fossils that are tropical plants. This was a hot time 56 million years ago. And then in the middle of that quiet swamp, hot Florida scene, no mountains, by the way. In the middle of that swamp, these cracks form. And these incredible lavas come up through the cracks and bury the swamp. And for a long time, I taught it as simply basalts. Like this is another flood basalt story, but 49 million years ago, instead of these far younger Columbia River basalt lavas. But I've since realized that there's rhyolites as well as basalts, different opposite types of lavas that are part of this Teanaway story. And I'm starting to realize that it's the rhyolite that is hosting the gold, maybe, and the blue agates for sure. So here's the swamp time. Here's the Squaw Formation. This is exposed on US 97. Interbedded sandstones and shales. Plenty of the shales, sometimes the sandstones, beautiful, large, palm fronds, other large tropical plants preserved in stone. We have some slabs in the hallways, both floors, if you want to wander and haven't seen them yet. This is the scene then for Washington before our big event. Our big event here today is 49 million years ago. That's the first major message. The gold and maybe the blue agates are both coming from a 49 million year old event that is right in the middle of this tranquil scene. So this is the tranquil scene before our main event. Washington immediately prior to 49 million years ago. This is not a total guess. This is a best case scenario for constructing the west coast of Washington. Let's pick a number. 50 million years ago. No, let's pick a number 55 million years ago. The south coast of Washington, that's a weird concept. Rivers flowing to the ocean, but the ocean, there is no Olympic Peninsula. I-5 was the coastline at this time, 55 million years ago. More rocks from that time. Okay, so we're here in this part of the story. So the Stewart granite is here, the Ingle serpentinite is here, the sandstones and shales are here, but we are about to have all hell break loose with our Teanaway Formation. If you haven't guessed it, The Teanaway Formation, the Teanaway lavas are part of something larger called the Challis Magmas. So my new leap forward, it might be new to most of you, is that our local lavas in the Liberty Gold District are part of a regional story going all the way back to Idaho, even Wyoming. The Absaricas, parts of the Idaho batholith, there's lots of lavas and magmas that are coming up at this time, and they tell different tectonic stories. Okay, so this is normally a cartoon showing the Columbia River basalt time 16 million years ago, but I'm telling you right now, if you were unaware, we had a more local scene like this 49 million years ago, the Teanaway. And if you know where to look, you can still see those cracks that have brown lava filling them and coming quickly to the surface. This is on the old Blewett Road. That's why I got you oriented properly. Here's the first hairpin as you get onto that squiggly road. It's one of my favorite outcrops. And this is the thickness of one of hundreds of basaltic feeder dikes that are tougher, more resistant than the sandstones and shales. And so they actually make ridges. And they actually cause the old Blewett Road to have squirrely hairpins. The road's trying to get around these resistant ridges, these basaltic picket fences. Oh, I like that. I'll keep that. So here's a map from more than 100 years ago. George Otis Smith was one of the first field geologists in the area. He was on horseback, and his map is still the best for mapping each. Look at how many of these feeder dikes or these basalt picket fences we have for getting you oriented. Here's Liberty, here's 97, and here's the old road going up and over. But they are everywhere, and they agree. There's a northeast-southwest trend to damn near every one of these feeder dikes coming up through the sandstones and shales. A more modern map shows the same thing. Can you see my green pointer down here? Here's US 97 today over New Blewett. This yellow squiggly that you might have to squint to see is Old Blewett. Here's all the sandstones of the Swauk Formation, and each of these red guys, you can see this incredible family. Those are these. So what did I learn from Rob Reppin? I learned that if you want to find crystalline wire gold, you might disagree with me or disagree with Rob, but the lesson I got from Rob is that we need to be specifically in this picture to better our chances of finding a hard rock mine that's going to have Liberty wire gold. We need to be in the Swauk. We need to be in black shale of the Swauk. That black shale needs to be right next to one of these feeder dikes. So we need heat, we need shale, and then we need water to circulate, maybe coming along these margins or what, I'm not sure. But that is the secret to finding the crystalline wire gold, and yet you zoom back out, take this in. I mean, this is just me with Sharpie marking pens. This is west coast of Washington all the way over to Hell's Canyon, Idaho. This is going back in time 60 million years. You're like, where the hell is what we're talking about today in all of this stuff? Here. So it's a challenge to fight through all these local names. I forgot I did this, but I'm realizing it right now. The red names are Washington geology names. The blue names are Oregon geology names. We got 4 or 5, half a dozen different names for the same stuff. It's just people have done different work at different places. So one of my favorite things to do is to pull out some stories, some regional stories, get rid of most of these names, and come up with some hokey color scheme or something to like just simplify the story and still try to be accurate as possible. But our Challis Magmas, you can see this is green, that's Idaho. The Challis Magmas, the Republic story up by in the north central Washington, the Wenatchee Pinnacles, it's this timeline we're talking about here. This time, now we're getting to the tectonics. I'm realizing I'm not going to go as quick as I want because this stuff's good. And I think it might be new to most of you. Even though you have a long history with the gold, this might be new to you. So maybe I won't be as quick as I thought. Once upon a time, there was an oceanic plateau known now as Silesia. It was a large oceanic plateau that built into an oceanic island. It got its neck up above sea level at one point. You can think Iceland, but it was much larger than Iceland. And the volume of the basalt in this thing called Silesia is far greater than the volume of the Columbia River basalts in the inland Pacific Northwest. So this was a monster pile of basalt. Why is that important? Well, we are confident now that Silesia, 50 million years ago, was starting to collide with the Pacific Northwest. Silesia was straddling this seafloor spreading center between two oceanic plates. Whoops. And most now in geology agree, have you heard this before? That the Yellowstone hotspot that we all know, which today is in Wyoming, 56 million years ago was out in the Pacific Ocean, offshore of Washington, and built this thing. And half of it is now in Alaska, and half of it is making up the Olympic Peninsula and the Coast Range of Oregon. So here are some beautiful brand new watercolors of Silesia, which could easily be much larger in this cartoon, but whatever, I'm getting greedy. And 53 million years ago, it starts to approach and starts to make landfall, or we slam into Silesia, however you want to think of it. There's debate about that. But this is the time and the aftermath of this collision that is setting the stage for our Teanaway lavas. So it's not a little isolated event to make the Liberty gold, it's a regional story. I'm talking to gold people. You know there's gold in Challis, Idaho. It's called the Challis Magmas after that mining town. You know there's gold in the Absaricas. You know, there's gold regionally in the Pacific Northwest Republic, and most of those gold deposits are from this time. It's not a random occurrence of gold being deposited in magmas all across the Pacific Northwest with different ages. It appears that most of the gold is showing up and being concentrated at this particular time. And notice what we're doing in this cartoon. We're breaking an oceanic plate, and we're having a piece of that oceanic plate break off and sink. This might also be new to you. Most of us were taught, if you took a geology class, that ocean plates subduct and then they eventually change state and they just become back into the asthenosphere underground. We now know that that's not true. And you can find slabs of ocean plate that are still as solid as they were when they're at the surface. You can find those things now in the mantle. And so now there's a new game called tomography to actually try to reconstruct which plate was where back in time. So today the Cascades look like this, but this is a far too orderly story for our Liberty Gold magmas, our Challis magmas. So if you were with me with the last 5 minutes, here's the same story, but with a slightly different presentation. This is mostly the work of a guy named Jeff Tepper, University of Puget Sound. And he's going to be lecturing here in this room in 2 weeks if you feel like you want to come back. So here's Silesia. Again, I think it could be a lot bigger. Here's the spreading ridge. He's got it offset. Here's the former coastline at I-5. Depending on who you talk to, the Columbia embayment existed or it didn't. Here's Iceland for comparison. 49 million years ago, you accrete or you add Silesia, and suddenly these red things are magmas being generated and coming up, and this is part of our Liberty story. This thing is a slab curtain. In other words, if you go down underneath Idaho, there's a slab that used to be part of the ocean floor that's now hanging vertically underneath Idaho. So there's an example of ocean plate that dives but doesn't disappear. It's hanging down there, known locally as the slab curtain of Idaho. So there's all sorts of debate and disagreement among scientists who are working on this. Here's yet another way to tell the story. We can't even agree on which plates were where. Most are now thinking the resurrection plate instead of the Kula plate was to the north, but not everybody's into that. Again, you get the idea that we're breaking a plate, which is odd. Why would you break one of these plates? It seems likely now that the accretion of Silesia, the adding of that huge landmass, jammed the oceanic trench. It clogged it up. And so the ocean plate that was connected to Silesia is going to tear. It's going to tear on the side. It's going to break where it was connected to Silesia because this is full of a landmass. It can't go down the tubes with the rest of the oceanic plate. So there's logic to where and when we're tearing and breaking oceanic slabs. Seems like I'm way off on a tangent, but I'm not. I'm trying to set the stage for why those magmas were eventually going to be hosting the gold and the blue agates. Here's a sexy image just showing you, first of all, here's Florida, the Great Lakes, Washington, California, Baja, and then what's this? Here's one piece of ocean slab that is now underneath us, and the colors are going deeper. As we go towards blue, we get further away from the surface and we get older oceanic material. Same thing underneath the Gulf of Mexico. This is the newest revolution in science. And the data, there's a bunch of research groups now working on these slabs to help us then. What the game is, you take these things that we know are down there, you go back in time and you slowly mentally bring those slabs back to a former ocean floor, and then you can have something meaningful about saying an ocean plate was at a certain place at a certain time. What I'm getting to is that the Challis magmas are not from a compressional time. The Challis magmas are not the result of a massive collision in a typical subducting plate. It's actually the opposite. The magmas that are hosting the Liberty Gold are from an extensional time, where we actually don't have a slab, and the crust is relaxing. And those fissures that we talked about that were sending magmas to the surface, those melts are being generated because we can get hot mantle shallower than it should be. And we're generating magmas that are weird. The Challis magmas are weird. They're not from a subduction story. That also is new for many of us, including myself. Generating lots of magmas, not from a simple downgoing slab in a compressional story, but the Challis magmas regionally are an extensional crustal relaxation story. This is going on today, apparently in Asia. I don't know, I just grabbed this someplace. But it's the idea that we've got this hole. There's no oceanic plate shielding the surface from the mantle, and so hot mantle is just surging up and triggering a bunch of decompression melting. Okay, I've got too many of these in here now, but maybe it's helpful to just keep seeing the same story. 50 million years ago, Silesia. This half of Silesia is now up in Alaska known as the Yakutat. So we had this monster thing that half of it's down here, that's what the S is, Silesia, that's us. The Yakutat is going to be taking a ride to the north on a San Andreas fault-like structure. So getting closer to home then, these are the 16 million year old flood basalts that most of us know. And perhaps you know that the northern edge of the CRBs are at Table Mountain, that photo I showed you earlier. They're at Lookout Mountain, just above Cle They're right at the edge of Wenatchee. They're right at the edge of Chelan. They're right at the edge. Basically, the Columbia here is following the edge of the flood basalts, the Columbia River basalts. That's pretty sweet. But the reason I'm showing this to you is that these red blotches are the Challis magmas. And why did they stop here, you say? Well, they didn't stop here. They got covered. This is a basaltic rug that's covering probably dozens more Challis magmas that we will never see because they're under 3 miles of basalt. So we're only getting a partial look. What else is new in geology? You never get a full look at everything. It's either been mostly eroded away or mostly buried. So we're just taking advantage of these few places we can see these Challis magmas. And you can correct me, but I think almost every red blotch has gold associated with it. Got crazy with there's only a few more of these left, okay? We're in the weeds now with tectonics, but I think it's interesting, possibly you as well. This guy Tepper has been studying Eocene magmas, granites primarily, but also lavas, and he has found an age pattern where not all of those red blotches are the same age. And he has now enough samples at enough locations to have an age sweep that we go from 52 million years ago to about 44 million years ago in central Washington. And he interprets that age sweep or that age pattern, and the Challis magma is getting younger as we go to the southwest, as an ocean plate starting to roll back or droop in the subsurface and then eventually break off. And what are the magmas generated when you actually break off that drooping slab? Teanaway basalts and others. So it's a very unique, precise thing. This is the best map I have for you for a brand new paper from Tepper. Teanaway basalt, basalt of Frost Mountain, basalt of Summit Creek, Natchez Formation. I don't know if these places mean anything to you. They barely mean something to me. I think this is Bulb Mountain, BP. What do you think? Can't think of it right now. This is a very distinct zone of bimodal volcanism, basalts and rhyolites together, coming up in a very distinct belt. And Tepper says, I don't think it's an accident. These are in a line. They parallel this margin where we're gluing Silesia on. And so he has a very distinct break at 49 million years ago to break the ocean plate and have these magmas coming up along this distinct, chopped off piece of this old Farallon plate. Skip it. Sharpie pen, whatever. I'm just trying to make sense of this for myself. Here's the Teanaway. And it's not far away from Liberty. We have gold in Wenatchee. But the Wenatchee, as I understand it, maybe as everybody understands it, the Wenatchee magmas are slightly younger and not exactly the same story as the Teanaway. What is the connection between the gold at Liberty and the gold at Wenatchee? Cannon Mine, that sort of thing. Nobody's really made that clear, I don't think. Okay, it's time for pretty pictures, and then we open it up to you. Rob, hard rock mine, up high. We need to be in black shale, next door to a basaltic feeder dike. We now have a general context why that basalt is there. It's surging to the surface because of the break in the subducting Farallon plate. Rob says, come on in, let me show you. I've got tunnels that were hand dug in the 1890s, I guess, 1880s. And he has quartz veins, calcite veins going through shale. It's calcite, isn't it? It's not quartz. I think it's calcite. It's calcite. These are calcite veins because the shale is carbon rich. So this is what his wire gold looks like in his hard rock tunnels above Liberty. And he dissolves the calcite in acid to break out his wire gold. As he told me casually, I don't know if that's your game, but he makes much of his capital from selling wire gold online. Oh, you like that one? We'll hang there for a second. What's the connection to Wenatchee? Saddle Rock, Castle Rock. In the same ballpark, how different is that gold in Wenatchee? I haven't gotten there yet. This is a photo from the Cannon Mine. And I tried to find whoever I could find from the Cannon Mine operation, which is basically in the city of Wenatchee, if you know Saddle Rock. The base is Saddle Rock. And these, I think, are calcite veins, although I can't be sure. I think this is black shale. Maybe it is the same vintage. I don't really know. Back to Liberty at Rob's place, right close to the Liberty Cafe along a very busy US 97. That's not Rob. But we have people 100 years ago doing the same thing. Now we're down low and we're in the placer. I don't have to tell you about the difference between placer and wire gold. I barely know much myself. But in the placer, under 50 feet of river rock, some of those boulders are incredibly big. I don't get why. That's what I'm impressed by. Why are these stones so large? Where's this river coming from? When are these stones being deposited? How far are these nuggets being transported? They're found in the pay layer at the very base of the 50 feet of river gravels and sitting right on top of the black shale basement. I know that the wire gold is 2 miles away and uphill, but I don't understand how you go from fragments of fragile wire gold and have it be compacted into these things in 2 miles. It just doesn't feel right to me, but what do I know? What we do know is that there are incredible nuggets from the potato patch and other places. So Rob has spent countless hours just willing to entertain whoever stops by. I don't know if he's still doing that or not, but he's into public education for whoever wants to learn about mining because he learned from people who are willing to teach him. So we have filmed him and made video programs. And here's back with Mike Corbley with the potato patch samples. Rob has been generous to allow my students to come out when I'm teaching Pacific Northwest geology, and he usually has it all set up so that he can do some discovery in the pay layer while we are there. And there's been incredible excitement from our students. So this is a very generous guy if you don't know him. His heart is in the right place. This is also not Rob. All right. All right. Well, there it is again. I guess I knew you would like this photo. I am showing it to you again. Okay, we got it. Back to the time before, the quiet time before. These are slightly out of order. I apologize. So we're back to the swamp before the 49 million year old storm of activity. These have been in the geology department here for 100 years. I've learned plenty going out to the Liberty Miners Rally. I've met some of you out there over the years. It's an easy drive for me to just drop in and give a little talk. And there's always interesting gold nuggets to look at. I guess that's pyrite in the black shale. Would you agree? I'm out of my knowledge of gold, so I'm coming to you momentarily. But I have expressed concern over, not concern, doubt's too strong also. I'm a little skeptical that we're compacting those, I just said it to you, that we're compacting those fragile wires into solid nuggets in the span of a mile and a half. And so that prompted more than once for somebody to say, hey, good talk, whatever. I want to show you. We've got nuggets that have this intermediate step. Like we have nuggets that are not densely compacted wires, but we've got these loosely held granola bar type wires. Doesn't that convince you then that this is all happening? I'm like, trying to be open-minded, but I'm having a hard time visualizing that in such a small area. It's just my hang-up, I guess. I've been trying to get the Washington Geological Survey interested in doing new work in the Liberty area with all those formations. And we do have a geologist who has an office just down the hall. He's based out of this department. And he does have history with hydrothermal mapping in Nevada. And so he's very interested in continuing his work. Currently, he has been assigned to map south of Ellensburg in the flood basalts, and it's not that interesting. So he's hoping to get out of the basalts and get into some, and maybe solve some of these interesting questions. I don't know if it helps you guys at all, but I just feel academically there's some really interesting problems to work on up there. Yeah, the Miners Rally. So in addition to Wes Engstrom and others that I've met over the years, I have met Carl Carlson at one of these rallies. And many of you know Carl. He, Carlson Brothers Jewelry in Tacoma. And so we transitioned just a bit before I quit. And I just want to show you a bunch of blue agate photos that I've collected over the years that probably do not rival what you have, but I'm going to share it anyway. In this room, Carl attended a lecture, I guess. I don't think he ever gave one here, but word got out that he's going to be in town, so these guys brought in their best samples. And Carl has done me a great service by saying, if you're going to teach about the blue agates, that lecture you have, he did it in a very nice way, Carl Carlson. He said, if you want to teach about the blue agates, I want to give you some samples that I think are going to give you a better answer for what's going on. That old lecture you have on YouTube is wrong. And I haven't taken it down, but I used to talk about the blue agates being formed in the vesicles of the Teanaway basalt. But Carl says, I've got mining claims that all of my best blues are not coming from the basalt. They're coming from the base of the basalt in the Teanaway rhyolite. And I'm like, I didn't even know there was rhyolite in the Teanaway Formation. He's like, of course there is. Wake up. He didn't say that. But I'm intrigued by this rhyolite, and I'm just starting to get seriously interested. And I'm doing a new series of live programs this winter, and the Teanaway rhyolite is on my list. Jim Landon, I just noticed you. Nice to see you here. So all of these blue agates, what is the actual age of the gold, and what is the actual age of these blue agates? I know they're both related to the Teanaway basalt/rhyolite, but that's the age of the lavas. Can we be sure at all about when the crystallization of the gold and the blues are happening? The only guy I'm aware of who's been in here really mapping and working carefully was a guy named Jacob Margolis, and did a PhD for the University of Washington back in the 80s. And somehow he came up with the number 44. Are the blue agates 44 million years old, not 49? And is the gold 44 million years ago and not 49? I honestly don't know what he based that number on. And we've got major advances in how to get precise ages on host rocks, but again, how do we date the gold itself, the actual crystals? How do we date the blue agates, the actual agates? Now I'm just going to pick up the pace. These are photos that I took down at the, what was it called? The Blue Agate Shop down on Main Street here. Steve Townsend was the owner, passed away a few years ago. Can't remember what they called that. I shouldn't have overthought it. The Ellensburg Rock Shop, thank you. So yeah, Steve brought out his best samples for the cameras, and other families that I swore that I would not identify them and their name, but they, secretly go in their backyard, like under a black curtains, like, you can take a couple pictures, thank you. So if you're unaware, these blue agates are passed down from generation to generation in the valley here and are prized. I'm just including them there because there is not a coincidence that these two very valued things, gold and blue agates, are coming roughly from the same time. Here's Carl, who gave me some of these samples to use for my teaching. So I bring them out, I dust them off every quarter when I'm teaching on the blue agates. And of course, every 19-year-old kid, whether they've heard about blue agates or not, is just swarming the front table. And I'm watching them very carefully. But Carl says, it's not basalt that's hosting the blue agates, young man. My blue agates are in a brecciated zone, and all the rock is shattered rhyolite. And my claims are in shattered rhyolite. And if you find some agates in the vesicles of the basalt, that's fine, but they're not the deep blue. You might disagree. But all of these samples, his best stuff, has rhyolite, not basalt, as the host. Most of these are like pretty blue things that people share with me. I don't have the expertise. You might go, that's not a blue agate. Maybe it's not. I don't know. But this is all Carl. Again, people are generous with their knowledge. And I know that you are as well. And it's much appreciated by those of us that don't know much about your expertise. Okay, I think I just want to just keep showing photos, but I want to open this up to questions at the same time, or comments. If you have, does anybody have any potential leads or answers for the gold that I'm asking about, or the blue agates? Yes?
So why would the uranium, thorium, helium method not work for determining the gold formation?
So why would the uranium, thorium, helium method not work for the age of gold crystallization? The way you asked your question means that you've probably done that work, and it's ignorance on my part.
It's a common method.
If it's a common method, that's news to me. So why hasn't that been done here? Or has it been done in any of the areas that have Challis magmas? Maybe that method has been used in other batches of gold. Like this, we know enough about the regional Challis story that we could hop, skip, and jump between these locations. And if there's a detailed study in Challis, Idaho, let's say, why couldn't we then extrapolate that over here? Great. Keep it going, please. Any comments along those lines would be extremely helpful. Please, yes?
Do you know the nature of the gold deposits that are west of Entiat?
West of Entiat, do I know anything about?
On the Chihuahua River that comes off of that ridge, and it's also on the other side of the ridge, I think some hard rock mines in that area as well.
Thank you for that. The Chihuahua, so we're in the North Cascades and sprinkle, so the answer is no. The answer in the North Cascades is there are these blotches. Let me go back to that map. It's not the most professional map, but there's blotches of red that are scattered all through the North Cascades, and many of those blotches are Eocene, which is the vintage that we need for this story. So I don't know how far you up the Entiat, but possibly we're up to one of these guys. Let me think. Can I think on my feet? The plutons that are Eocene age that are potentially part of this story. The Golden Horn batholith, the Cooper Mountain batholith. There's two other famous ones in the North Cascades that might be tied to your gold up in the Chihuahua, but I don't know the details well enough. Yes?
And the second question is what's the rock type, major rock type on top of Red Top?
On top of Red Top is Teanaway basalt. So has anybody found excellent blue agates on top of Red Top? There's plenty of agates, but are they the deepest blue? I'm not sure they are. And so that's the message I'm getting from Carl. So that Teanaway basalt, which is, if I go back to that Teanaway basalt this is Red Top right here. So this capping basalt. So in other words, if you're on a, so the surface used to be flat. So this thing used to be flat, and these feeder dikes used to be vertical. And then there's been folding since that time to get the Teanaway basalt. So I'm saying, because Carl Carlson, my main source, is saying that there's agates all through this capping thick Teanaway basalt, the basalt that buried the swamp, but it's the base, the very base, the first explosions that set off this Teanaway story, probably before the dikes, I guess, that have the blues. Does that mean the blues are in the first days of this 49 million-year-old event? Or again, are the blues being formed millions of years later by some sort of hydrothermal event? Yes?
Just a quick question. Has anybody determined what the color center or the molecular formation is causing the blue?
Has anybody worked in detail with the blues to scientifically understand why they're so deeply blue? There was a woman named Angela Halfpenny who was up on the third floor in this building. That was her main project. And before her was a mineralogist named Paul Hoskin, and they were very interested in getting into the details of that. I don't know how to summarize the work. Was there somebody with their hand up that had an answer? Yeah.
Talk on that once in Colorado, and the guy said that in between the chalcedony fibers were little spears of silica.
Yes.
A little gap between the fibers and silica was the right wavelength, that it kept them stable blue.
So it's more of a physics answer than a chemistry answer. Yes, that sounds familiar. So to repeat that, it seems like a leading idea, maybe scientifically documented, is that the blue color is coming from a physics refraction or reflection of light with little spheres at a very tiny level, as opposed to chemical impurities. That's maybe where we'll stand there. Yes?
Does Holly blue have any relationship to Ellensburg?
I don't, help us out here. Holly, gentleman right here, does Holly blue?
Not that I know of.
No?
I'm not Holly's expert.
Okay.
Pretty different. Yeah.
Probably not, but we're using the expertise in the room now. I'm more of a moderator at this point. Yes?
I don't know about this, but I recently read some research that there's a relationship between quartz and gold that's piezoelectric, and that when there's earthquakes, there's like a voltage that's created when quartz warps, because quartz has piezoelectric elements to it, and that all the gold, like when it's soft and liquid, it tends to like cluster together across areas where you get the electricity from it. And I'm just curious that like this whole region is like really seismically active.
Yes.
And if there's like any relationship between how gold is tends to like cluster together and that.
Thank you. I think you all know what we're doing now. We're just sharing ideas that we have and wondering if somebody else has worked on it. This thought is involving seismic history, earthquake history, and gold associated with seismic activity, and then as gold is somehow being deposited with a series of earthquake activities. Are we talking about earthquake history with some of the Liberty gold? I don't think anybody has a clear answer, so why not entertain anything that comes up? A few more, yes.
Just two things. One, I recently mentioned holly blue, and I think, isn't it purple?
Holly blue is more purple than blue, so maybe that's a different animal that we're talking about today. Yeah.
Question is, I actually have some, supposedly Ellensburg blues collected. I didn't collect them, but a guy by the name of Paul Rhodes collected it. And I noticed that it has a distinct color change. If it's like in sunlight or incandescent, it's got the nice blue. But even under fluorescent light, it really actually has the blue kind of gets washed out. It's a noticeable color change. Is anybody?
So just to go back, you guys already said the color, it's a Rayleigh scattering. And it's very sensitive to the sunlight spectrum.
Yeah.
And so the color is going to change pretty strongly. But it's the same, believe it or not, Rayleigh scattering for this is exactly the same reason your sky's blue. It's an identical mechanism within the silica. And I think it's a pretty strong
I didn't hear that whole thing, but very noticeable color change.
Well, it's a common experience for somebody to come in to my office and expect that I know everything about blue agates, which I don't, but it's awkward. So then they go, well, let me show you my best stuff. And they're like, wait a minute, this thing was so blue a few days ago when I found it. Now the thing's gray. So yes, it's a common experience. A few more before we quit. About back to the gold, maybe? Yeah, either way.
Maybe you showed this fairly large body here with Wenatchee, and so I thought this is more an andesite, and we were using actually some amphiboles from there.
Yeah.
Some collectors noticed here this was a question whether this was actually a Hastings site. It turns out to be Sadanagai. And from that composition of the amphibole, they are sort of a geobarometer. We determined that, and I don't have the number here, but that's unusual depth of this andesite source. Is that something useful here to think?
It might be. Let me try to.
Then going to your breakout of that slab.
Right.
It just opens a channel from real deep where this andesite source could come from.
So I'll try to rephrase for everybody. In the Wenatchee area, which is now the pinnacles that are above downtown Wenatchee primarily, there's a mixture of rhyodacite and andesites and gabbros and lots of different compositions. The report is that there's some mineralogy that indicates that much of that magmatism around Wenatchee is possibly a deeper source than maybe some of these other magmas. And the age is also a little bit younger, as I understand it currently. So the major break is in a distinct belt at 49. I'm quite confident those Wenatchee magmas are younger than that. And those are the magmas. And then again, is the mineralogy and the gold mineralization specifically tied to that. I mean, I was stunned by these dikes that are mostly going across sandstones. So the Swauk sandstones, we're in the Wenatchee area now, in the Cannon Gold. They're talking about reefs, as they call them, and this is, I think, fundamentally different than what's going on at Liberty as far as even the host rock is concerned. So I know of nobody really working carefully to tie these two gold districts together. That'll be a fascinating study to see how your differences with those magmas in Wenatchee, is it apples and oranges between Liberty and Wenatchee? It's kind of strange that they would be so close together and be roughly the same vintage, but maybe it's true. Yes?
So north of Liberty, you have the town site of Blewett.
Yeah.
And it's a famous low gold mining area, plus placer mining originally.
Mm-hmm.
And that is calcite veins and serpentine.
Thank you.
Go a little bit south of Blewett, along the highway, you get into the sedimentary rocks, and there's placer gold all the way, almost all the way up to Swauk Pass.
Okay.
The new highway.
Right in here, yeah.
Is there a tie-in with the Liberties to the, number one, the Blewett mines? it seems, because one's got sedimentary rock faces versus the igneous. And then south of Blewett, you're back into the sedimentary, and yet it's still producing placer gold. And it's uphill from Blewett.
Right.
So is there a tie-in?
There could be. Maybe I'm misremembering. With the gold, maybe there's a sedimentary main story for those gold deposits at Blewett, up to Swauk, and then even down to Liberty. And maybe there is more of a commonality with the sedimentary story that I know better in Wenatchee than I do in Liberty.
Because I've panned up in those streams uphill from Blewett, and yeah, there's placer gold quite a ways uphill there. I don't think it goes all the way to the pass, but it's definitely much higher up than Blewett, and there's definitely sedimentary rocks in there.
Thank you. Let me finish with this, and it's a question open to anybody. If you've had any history with the placer nuggets in the Liberty District, how far do you think those nuggets were transported? I personally am wondering if those nuggets were carried tens of miles, and there could have been a source that's now in southeastern Washington underneath all the flood basalts. Like, I know these placer nuggets are found in the sedimentary Swauk formation now, but are we sure that even though they're big and round, that they were all formed right there? That's ultimately what I'm curious about. Anybody got any thoughts about that? Yeah.
Big boulders, the same.
Big boulders. I mean, they are watermelons and bigger than that and perfectly round. I don't see how you can do that in a mile and a half.
Are they recent or was that?
Say again?
There's a chemical difference between the big nuggets and the wire.
Okay, a difference between that and the wire?
There's a chemical difference.
The chemical difference? In the placer versus the wire?
Yeah.
Couldn't you look at the micro, the other elements in there and see if it's the same profile between them?
Sure. Couldn't you just analyze chemically a bunch of potatoes, nuggets, and the wire, and if there's a fundamental chemistry difference, just like a rock difference, you would have a totally different story between the two. I guess that's been done. I don't know.
They do it to validate.
So, the question you had about how far can they be transported, I don't know anything about these, but I'll tell you that we have many regions, for example, Sonoran gold nuggets, which we can use the trace chemistry to trace them back, and they're transported about 800 miles. And so given given enough time, geology can do anything, right?
Yeah. 800 miles.
And very large nuggets.
I mean, I just find that's to me one of the most fascinating things about that. I'm not going to forget that comment. I'm going to be thinking about that, drawing circles 800 miles in radius around Liberty. Thanks for your attention, everybody. Appreciate it. Thank you.